Dear students, Assalamu alaikum. Welcome to week 8 of our online machine learning sessions. Hopefully, we will conclude today all our material which we had to cover in this lecture. So, as you know, that we were discussing our unsupervised learning domain, and we were talking about clustering in our previous lectures. And in clustering, we have seen one algorithm so far, which was K-means clustering algorithm, and we had a detailed discussion on the working, the algorithm, and we have seen a number of examples. I think we have studied 3 different examples in which we have seen that how can we perform clustering through K-means algorithm. So that was our first algorithm in which we had a basic understanding of how we can perform clustering or groupings of different objects which have some similar attributes or some similar characteristics. So in today's lecture, we will go a little bit further and we will have a look at some other algorithms which are also very powerful yet simple algorithms, and they have been used to perform clustering of different kinds of data. So mainly we will be seeing our SOM algorithm, which is known as self-organizing maps. Also we will be looking in K nearest neighbors algorithm, and then we will also have a look at the expectation maximization algorithms. So as I have told you earlier, that all these algorithms are used in order to perform clustering or groupings in an unsupervised learning domain. And you know that in unsupervised learning domain, we don't have the labels or target values, right? So we have unlabeled data, and the procedure is somewhat same because we divide our data set to a training set and a test set or validation set, and then after training an algorithm we can test how the algorithm is performing. But the only difference is that since we don't have labels, so that's why we are basically creating groups or clusters depending upon the characteristics or the attributes present in the data itself. And you have seen that in K-means clustering, we basically use the characteristics of the data itself, and then we basically made their different clusters. So let's have a look at another algorithm, which is K nearest neighbors algorithm, which is also known as KNN. And we also, similar to K-means, we also use this for clustering. So in as you can see in this figure, that we have different classes of data, or you can say different groups of data, and we have an unknown variable in the middle, right? So we don't know that this unknown algorithm or unknown variable, where should we assign, I mean which class or which group should contain this unknown variable. And you know, in clustering or in groupings, we basically need to assign the unknown variables to their associated groups or classes, right? So the basic concept is the same as we studied in K-means clustering algorithm, but where the procedure is a little bit different. So K nearest neighbors have different names. It is mostly known as K nearest neighbors, but sometimes it is also known as memory based reasoning. People also call it as example based reasoning or instance based reasoning, and sometimes it is also known as lazy learning. So what is a KNN? A KNN is a powerful classification algorithm which is used in pattern recognition or pattern classification. K nearest neighbor stores all variable cases and classifies new cases based on a similarity measure, for example distance measure. So as you have seen that in K-means algorithm we studied 5 different kinds of distance functions, right? And we saw that there are 3 most commonly used distance functions which are being used in different clustering algorithms, and one of those distance measures is a Euclidean distance, right? Sometimes people also use Manhattan distance, but Euclidean distance is the most commonly used distance measure or distance function which people use in most of the clustering algorithms, whether it is k-means or knn or it is self-organizing maps. And on the top, or one of the top data mining algorithm used today is knn, and people tend to use knns in order to find attributes or similar patterns in different sets of data. A non-parametric lazy learning algorithm and instance learning algorithm. So it is also known as instance-based learning, and let's have a look that why it is called instance-based learning. So in a KNN classification approach, what is the basic approach or algorithm behind it is that an object or a new instance, we are calling an unknown entity or an unknown object, and we are treating it as a new instance. So a new instance can be classified by a majority vote of its neighbor classes, right? So that's why you can also see that why we are calling it as k nearest neighbors algorithm, because in KNN algorithm, the new instance is being classified based on the votes by its neighboring classes. So it has some neighbors, and those neighbors will be voting for the new instance, and based on their majority votes, we will decide that which cluster or which group the new instance belongs to. The object is assigned to the most common class among its k nearest neighbors, made by a distance function. So we are using a distance function, and that distance function will basically tells us the distance of the unknown instance to different instances which are acting as their neighbors. So here is a graph. Let's see an example. So we have two different groups or sets of data, which one is represented as red and the other is represented as blue. So we have an unknown instance in the middle, which is represented with green line, green color here, and we basically calculate the distance of this green dot, which is unknown instance, to its neighboring instances. So the distance measure is basically computing the distance of an unknown object. So in this example, if we have unknown object here, then we will have a radius of circle here, right? And the object or instances lying within that radius or circle, we will compute their distances from the unknown object or test record here in this case. So we can say that we need to choose a value of k, and that value of k will basically decide the nearest neighbors of this unknown instance, and we can treat all these nearest neighbors as the training records, and we compute the distance of each training record to the unknown object. So we as we have also already seen different distance measures already, so I don't think that I need to explain these equations again, but as I told you earlier, that most commonly used distance function is the Euclidean distance, which we have already seen in k-means, and we have seen 3 different examples on Euclidean distance. So we will be using this distance function in our KNN algorithm as well. So here is the basic algorithm of KNN algorithm, in which we are basically calculating the distance between neighbors. So we calculate the distance between new examples and all the examples in the training set. So we have a number of examples in the training set, a number of instances present in the training set, and we are calculating the distance of the unknown example or the new example with each example present in the training set. And we have Euclidean distance between two examples. So for each example, we are using the distance measure in order to calculate the distance. And you know that for two instances, x and y, the distance measure can be represented by this equation here. So now let's have a detailed look at on the steps of a k nearest neighbors algorithm.